Hello, physics people, and welcome to this segment on fluids and pressure and hydraulics. So, a guy named Blaise Pascal, a long time ago, he figured out that if you have a fluid, right? So, say I have a reservoir here, and say that it's connected to another one over here, right? Let's make these both open like this. And let's say that this has fluid in it, right? So what he found was that if he was to take and maybe take a piston like this and push down on this fluid right here, that the force would transfer all the way through the fluid, and that it would be completely undiminished. So whatever force he put on right here would actually transfer all the way through undiminished to the other side. And so then we actually were able to create the science of hydraulics. So hydraulics are really, really cool, and this is what we use now to lift incredibly heavy things. You may have used a hydraulic jack in order to lift up a car or something. So here's the idea with a hydraulic jack. What you have is you have this end over here that lifts the load. Now notice that this is a much bigger surface area. Okay, and so then this is a smaller surface area. It's probably a lot smaller even than this picture shows, but what has happened is you've changed the amount of surface area that you're putting pressure on here, putting force on. So you have a small surface area over a small force. So your surface area is small. And so then that means your force can be small to get the same pressure. It's going to give you a pressure. Now, if that force transfers all the way through and the pressure remains constant, right? And it comes out on the other side, and so we have the same pressure going in or coming out, the same pressure on this side. If I put pressure on this side and the same pressure comes out that side, well, then I'm going to have a lot larger force because I have a lot larger surface area. So basically, the idea for hydraulics is that the pressure equals the pressure. So pressure 1 equals pressure 2, right? And we talked about how pressure equals force divided by surface area. So basically, force 1 divided by surface area 1 equals force 2 divided by surface area 2. And so you can figure out a lot of stuff this way. I just... So let's do a quick little problem here with hydraulics, and I'll show you how this works. So let's say that this is my jack right here, and this is just kind of a general diagram showing you how this looks right here. But let's say that, like, I know some things. Let's say that I know that the surface area of this smaller one is 72 square centimeters. All right. Let's say that I know the surface area of my big one over here is 1,440 square centimeters. So this is going to be the surface area of this piston on the top here, the surface area of this fluid. And let's say that I know that the load that I need to lift is 1,600 newtons. So then the question is that in this contraption right here, how much force am I going to have to put on this smaller one in order to get the same amount or this 1600 force over here. So let's go ahead and plug it in. So my force 1, we'll say, is this one. I don't know what that is, but I do know that my surface area 1 is 72 square centimeters, and that's going to equal my force 2, which is 1600 newtons, divided by 1440 centimeters squared. And so I'm going to go ahead and divide these together and then multiply by this, and I find out that my answer is 80 newtons. So you can see that it's a significantly smaller force. Now, what you have to do, though, in hydraulics is you have to look at what's the difference here. What's the difference of force here to force coming out? And actually, as we've talked about pressure, we've talked about forces. We know that any machine works by changing the distance over which the force is exerted. And so we can change the distance, and so that's actually what happens here. So if we were to take 1600 and divide it by 80, we would find out that there's 20 times the difference there. And so actually, I'm going to have to move this down 20 times more then I will have to, then this will go up. So I don't know if you've ever noticed, but when you're doing a jack, this is going up and down. You're pumping up and down, up and down. So they put pumps in these things so that you can essentially move something 20 times to get this to move however you want it. So for every 20 pumps, this will go, that equivalent distance that it puts out for 1600 newtons. So you probably will have noticed that when you're jacking up a car, you got to pump, and the car just goes up a little tiny bit. So, with any machine, we have also this connection of changing distance and force. So there's a lot of really cool stuff with what fluids do. Hydraulics is one of them, and by utilizing a pump system and by utilizing this Pascal's principle, where the fluid transfers the force unaltered all the way through it, we can take a very small force over here and transfer it through a fluid and lift huge loads. So we have enormous loads that are being lifted. So that's simply how you do it. Here's your simple equation right here for figuring out the stuff you would need to know for hydraulics. And that concludes that. We're going to look at buoyancy, or actually pressure that is caused by going underwater, in the next video.